In this video, I will go over how to use Adaptive Focus Control, or AFC, in your Navigator experiments. AFC is a hardware autofocus mechanism that is available on DMI-8 microscopes. It works by sending an infrared beam up to your sample and looking for the difference in refractive index. It communicates with the motorized focus and adjusts the focus to the offset that is determined by the user. Now, there are a couple of things that will work with AFC and won't work with AFC. One is that not all microscope objectives are AFC compatible. If this light is green, then you're good to go. If you are not using an AFC compatible objective, this light will not be on. The other thing is that AFC will work better when there's a big difference in refractive index. So for instance, for a dry objective, the infrared beam is going through air and then hits cover glass or plastic, and that's the interface where there's a big difference in refractive index. These are great samples to use with AFC. You may experience less stable performance when trying to use AFC with an oil immersion lens and a fixed sample because there's less difference in refractive index. So here I am imaging fixed tissue on a slide with a 20x air objective. If you don't have AFC, which you would be able to find under the autofocus panel, then you can always use Focus Map, which I cover in another video, or high-speed autofocus or best focus, depending on whether or not you have Synapse. So another tip with AFC is that your sample should be pretty close to the cover slip and relatively flat. So if you have something that may be embedded in Matrigel or something that's a little bit further away from the cover slip or with variable focus, then AFC may not work for you. So in order to access this panel in Navigator, so first of all, let's launch Navigator. So to launch the autofocus panel, I actually have to go to Image here and select this Show Auto Speed. So when I toggle this, it goes off, and then when I toggle it, it's red, it comes back on, and then I have this autofocus panel on the left side. Under the focus system, I will choose Adaptive Focus Control. You'll see a green light here when we're using AFC compatible objectives, when AFC is inside the range and the device is active. You can also turn the AFC on and off in this window. We can switch between continuous mode and on-demand mode. Typically for an experiment where we are only taking one plane, we want to select continuous mode. However, if you're doing an experiment with Z-stacks, you'll need to use on-demand mode. If you're doing multi-position or time-lapse experiments, then you will also have access to these two buttons here, time-lapse and stage, where you can execute AFC on demand for specific positions or all positions or time points. So here's an example of an image that I took without AFC. You can see that there are some areas here that are very much in focus, while others are out of focus. And while I can also apply a focus map to this piece of tissue, I can also apply Adaptive Focus Control for hardware autofocus. So to do that, I want to go live. And then I'll go to my autofocus panel, choose continuous mode, focus, and then select hold current position. Then I will start my experiment. Let's compare the image I just took with the AFC on to the one I took before without AFC. So again, this is the one that I took without AFC. You can see the out of focus areas. The one I took with AFC is much better. Let's focus on this region here. Out of focus, in focus with AFC. So if you're having issues getting an in-focus image with AFC, make sure that your objective is compatible and that your sample is clean and flat, and that the AFC position is holding green the whole time you're imaging. It always helps to have high quality imaging chambers. Even if you're using plastic, there is optical grade plastic that is more consistent in thickness that will help with the AFC. As always, if you're having issues, please consult with your local friendly imaging specialist.